a lot of people, this is their favorite unit of trigonometry. I think, like, from here on out, I just think trig is super cool. I can't think of a unit we cover that isn't fun. But this one, kids seem to really gravitate towards. And you remember when we were solving right triangles that we use that thing called SOHCAHTOA? We only spent a day on it. And overall in this class, you guys did a great job solving SOHCAHTOA on the test. Well, today the big question is, what if you're given a triangle that's not a right triangle? So like this triangle here, it doesn't have any right angles in it. How do we solve that kind of triangle? So I'm not gonna give you the formula, we're gonna derive it. It's not very difficult. You need to start to appreciate that part of the beauty of mathematics, we don't make anything up. It comes from pieces we already know. And someday, if you, depending on if you pursue a math degree or not, that's all you do in some courses is just prove problems. In fact, I had 2 classes in college where I got writing credits because all you did was prove problems, and so you got a writing credit because you wrote so much for the proofs. Actually, the professor who taught the class, he had a doctorate in mathematics and a doctorate in English. So he would first go through and make sure that our proofs were mathematically correct, and then he would go through and make sure they were grammatically correct. It was super cool. Some of the smartest people I ever met in my life. We won't go that far, but we will teach you how to do this. Triangle A, B, and C with sides A, B, and C. In previous triangles, we said that if you had a right triangle, the C was always 90 degrees, right? That's not the case here. And so I want to say something intelligent. In order to say something intelligent, I'm going to drop down an altitude and label it as H for height. It has a 90-degree angle. Now, you're like, well, Mr. Gantz, you just totally cheated. You told us you weren't going to work with right triangles. Now all of a sudden you put a right angle there. Point taken. But I'll make the H go away eventually. Okay? So, which trig function, sine, cosine, or tangent, has to do with those 3 parts? Sine. Sine of angle A is the opposite divided by the hypotenuse. Everybody agreed? Good. Let's write that down. Sine of angle A is equal to H over B. Then, let's check out this part. Which trig function deals with H, A, and B? Sine again. Sine is the opposite divided by the hypotenuse. So we also have the sine of angle B is equal to H over A. What do you notice those 2 equations share in common with each other? They both have an H. And so we're going to use that to our advantage. We want to make the H go away eventually because in most triangles we're not given that right angle. So I'm going to show you how we can do that. I'm going to multiply both sides by B, and I get B sine of angle A is equal to A sine, well, I'm sorry. If I multiply both sides by B, I get B sine of A is equal to H. Sorry about that. Got too far ahead of myself. And if you multiply both sides by A, you get A sine of B is equal to H. Are you okay with that? So let's use some logic. If both things are equal to H, then they're both equal to each other. And so all of a sudden you can say B sine of A is equal to A sine of B. Notice how the H went away. And to clean it up, I'm going to choose to divide both sides by AB. That's the thing you can do in math, right? You can divide both sides by the same thing. And on the left side, if you divide both sides by AB, what's going to happen? The B's cancel and you get sine of angle A divided by side A is equal to, and on the right-hand side, the A's cancel. And you get sine of angle B divided by side B. Does that look familiar to anybody? You did not cover this in geometry at all? Not even for like a day? Okay, we've suppressed it. That's all right. It's called the law of sines. Given a triangle ABC with sides A, B, and C, we know this to be true. Sine of angle A divided by its opposite side, which would be side A, is equal to the sine of angle B divided by its opposite side, side B, which is equal to sine of angle C divided by its opposite side, side C. The law of sines. The key is you must be given an angle and its opposite side, and if you are, you can solve it. Yeah, it's a really handy formula to use in trigonometry. Question? The angles are not equal, but the sine of the angle divided by its opposite side. So it's like a ratio almost. You know what I mean? That ratio stays constant. So we're going to solve this triangle, kind of like we always solve triangles before. We're going to do these two examples. And we're going to teach you some things that you maybe suppressed during your time of geometry for whatever reason. Maybe it was during COVID. Maybe you were just really bored. I don't know, but it's gone. We're going to bring it back. 42 degrees, 80 degrees, and A is side 10. Here we go. Sorry, my smartboard is struggling right now. There we go. I put in 42 degrees for angle A. I put in 80 degrees for angle B. And side A is 10. Sir. There's a couple ways to start this problem, but before we're going to do that, we're going to start to classify this triangle. So what I want you to do is I want you to flip to the very back page of your notes. And as you flip to the back page of your notes, you should see a sheet that looks like this. This is what you get to use on the test. Okay? Now, as you look at it right away, some of it might seem confusing. Every once in a while, I have a student that they'll get done with the test and they don't do very well, and I'll say, well, how did you follow the sheet? And they'll get kind of angry. They're like, I couldn't understand your sheet. Okay, make your own. Make it better. You're welcome to. This is not developed just from me. This was developed by me after talking with kids for 5 years of teaching this, and most people find this extremely helpful. I have teachers all across Minnesota and other areas that reach out to me, say, Mr. Gens, can I please have your graphic organizer? It's simply the best one we've seen. It really works quite well. This is what we want to happen in your brain. Now, before you can make it happen in your brain, I'd like you to see it all out in front of you. But it starts with these classifications up here. Do you remember seeing these letters during your geometry time? About 50% of you know what these letters mean, but 50% of you have confused what these letters mean. We cannot move forward. You will not do well on this test until you get these classifications correct. So you must focus. Many of you do not already know this, even though you think you do. Okay? So what part of what you learned in geometry was that angle, angle, angle did not prove triangle congruence. And so you see that there is no solution here. Another thing that you learned is if you came up with SSA, which is ASS backwards, right? This is the donkey issue, right? This is your teacher taught you that. That's where you get problems, right? Yeah. So you can see that if you follow this down, we end up with all sorts of crazy stuff down here. We don't like that path. But some of these other ones, they work out pretty well in terms of triangle congruence. So as I flip back to my original problem, the question is, as you look at this triangle, what kind of triangle is that? Is that a side-side angle? Is it a side-side-side? Is it a side-angle-side? Is it an angle-side-angle? You talk to your peer for about a minute and see if you can classify which one of the 6 is it and why. Decide. Go. Talk. 5, 4, 3, 2, 1. And let's talk about what it's not. It's not side-side-side, right? And it's not angle, angle, angle. we've got two angles at one side, so therefore it has to be either angle, angle, side, or it must be angle, side, angle. Just to be clear, we say that side, angle, angle, and angle, angle, side, those are the same. Those are the same things, okay? So which one is it? Is it angle, angle, side, or is it angle, side, angle? Which one? Why? But if I read this off, if I start with the 42, I go angle, angle, side. See that? But if I start with the 80, then I got angle, side, angle. And if you start with the 42 and go backwards, you got angle, side, angle. But if you start with the 10, you got side, angle, angle. Do you see? Like, where do you start? Isn't that confusing? But Erin's 100% correct. And this is what you guys have to see. You have to see exactly what she saw. It must be angle, angle, side. And this is why. See how the S sits between the angle and the other angle? It has nothing to do with the order in which you read it. It has to do with the location of the side. Does the side sit between the two angles or outside of the two angles? Look at the 10. Does that sit between 80 and 42? No. If the 10 was here, then it would be angle, side, angle, because it's between those two. As she said, sandwich between them. Do you see the difference? So because it doesn't sit there, this is an angle, angle, side scenario. Angle, angle, side. And so what you can do with your sheet is once you know what kind of triangle it is, you can then go ahead and look at it. It says angle, angle, side. If you're given that scenario, there's just one solution. You're just going to use the law of sines, and everything is good. Today, all you're going to practice is one solution using the law of sines, because we need to get good at it. You need to be fast at this. So let's try to set it up and see how we go. I want to set up the law of sines. What would be your first part for setting up the law of sines? Sine of 42 over, you need its opposite side, which is 10, is equal to the sine of 80 divided by x or b. I'll call it b so we know which side we're going for. How would you solve something set up like that? Cross multiply. 10 times the sine of 80 is equal to b times the sine of 42. Now I want to solve for b, so I simply divide both sides by sine of 42. So 10 sine of 80 divided by the sine of 42 is equal to b. The sine of 42. So I turn my calculator on. I check to make sure I'm working in degrees and not radians. And I take 10 sine of 80 and I divide it by the sine of 42. And I get 14.72. That's B. Oh boy. Kind of embarrassing. Sorry, everybody. We're not going to take that one. I should turn it off, shouldn't I? How do you do that? Sound. Okay. What's the next easiest part to find? The angle, because they all add to 180. And my math says I'm going 58. Good with that? Okay. Now for side C, we can just use what? It's not a right triangle, so you can't use a Pythagorean theorem, folks. You got to have a 90-degree angle. So we use the law of sines again. We set up sine of 42 over 10 is equal to the sine of what over what? 58 over C. Yeah, and I'm going to show you what I want you guys to get good at when you're working through your assignment today. So as we cross multiply, can you see that you're going to multiply the 10 and the sine of 58? But you're going to end up dividing by the sine of 42. So that way it saves me a little bit of writing, and I can go 10 sine of 58 divided by the sine of 42. So that's trying to develop some quickness, because we don't want to waste time using the law of sines on the test. You got other things that are a lot harder than that. So 12.67. Now, as I try to confirm whether or not my answer is reasonable, notice that I have the smallest angle is opposite the smallest side, and the largest angle is opposite the largest side. So my answer is reasonable. Good? Okay, we try the next one. I'll set the triangle up, and then you guys can have a conversation. A, B, and C. Hi. Five, four, three, two, one. Everybody agree it's got to be two sides and an angle. So which one is it? As we glance, we say if it's side, angle, side, the angle sits between the two sides. So if the 12 sat there, then it's side, angle, side. But the 12 doesn't sit in between those. As Aaron said, it's not sandwiched between. So therefore, we are sitting as a side-side angle situation. Okay? Everybody see that? So let's take a look at our sheet and see what does it say about side-side angle. It says that's the donkey situation. You end up with some challenges. You go down, you take a left, then a right, and then you either got to go to the side or this side. So we're going to decide which side to go to. It says the side opposite the angle is longer than the other given side, or the side opposite the angle is shorter than the other given side. Let's check with our triangle. Is the side opposite the angle, is it longer or shorter than the other side? It's longer. Those are all the situations you'll be given today if it's SSA. They'll always be longer. That's how I've set this up, okay? And you can be confident then, as you look at your decision tree, it says there's one solution using the law of sines. Okay? Good? All right, so let's figure out how to solve that one, and we can let you on your way. We've got these pieces. Notice this time I'm given two sides, only one angle, so that's different. How are you going to start by setting this up? Sine of what? Good. Sine of 12 degrees divided by side 12 is equal to the sine of angle A divided by side 10. So now we don't know an angle. Instead of cross multiplying here, I'm just going to multiply both sides by 10. So 10 sine of 12 over 12 is equal to the sine of A. So on my calculator, I'm going to take 10 sine of 12 divided by 12. And I get this decimal, this 0.1732. No. Do you remember when we were doing right triangle trig, do you remember if you were trying to find an angle, what did you press on your calculator? Yeah, you did the second sign, right? So if you're trying to find the angle, you have to do second sine of that. So I go second sine, and this is a trick, in case you guys didn't notice. If I want to plug that thing in right here, all I have to do is just second answer, and it pops the A and S right here, so it just takes this thing and plugs it right in there, and I get 9.98. So that means that angle A is 9.98 degrees. What's the next easiest part to find? Whoop. Second, and then see the A and S.
Okay, got it.
There you go. Yep. Okay, so finding the angle. All angles have to add up to 180, so 180 minus 12 minus 9.98. I get 158.02. Sweet. Pythagorean theorem? No, it's not a right angle or right triangle, so I can't do that. So you have to set up, we'll go sine of 12 over 12 again, kind of like that, equals, and then what's the second piece? Way to go, Izzy. And this is where it's helpful to have a little bit of that speed built up, is I notice that I'm going to multiply these two, and I'm going to divide that off, right? So that helps me type it in, 12 sine of 158.02, and divided by the sine of 12. And if you have to write it out, it's okay. I just want to show you how you want to try to eventually save some time. 21.60. So there we have it. I noticed that the 158 should give me my largest side, and it sure does. All right? Take out your homework. It's not what you got? You're supposed to not divide by 12, but by the sine of 12. Better? Okay. As you look at your first assignment, the first two problems say example 1 and example 2. You do not need to do example 1 and example 2. We may choose to use those as a checkpoint or something. But you are a highly intelligent group, and we don't need to spend more time doing those. I've reduced it from 10 problems down to 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. Please do those, but please note this. All of the problems on the left side will work out like this, where they're all two angles and a side, so there's just one solution. And you'll be starting by solving for a side. All the problems on the right-hand side will be like this, where you have the SSA, but it's only one solution. And you're going to be finding that angle right away, okay? So I give you practice with them both. You want to be excellent at this, everybody. You must come to class tomorrow and have at least the first 4 completed. At least the first 4 completed. After you do the first 4, you should be able to feel pretty quick and get through the next 4 a lot quicker. But tomorrow is the hardest lesson in the unit. You can make it through tomorrow, or you can get an A+ on the test. But what we cover tomorrow, a third of the class, you'll continue to have questions for the rest of this unit about it. People really got to be present and focused. It's not super tough, and the decision tree helps a lot. But I just want to warn you. Oh, by the way, the last thing on your homework sheet is not an assignment. This is totally optional. It says extensions. But the fact is that some people get bored with class. It's just too easy for them. Good for them, right? So if you want a little bit of a challenge, those extension problems on the end, they're really good. Yeah, they're great. I love them. So you can try them out if you want. The rest of the time is yours. I'm subbing for Mr. Luther.
Yeah, I'll have you.